Hi everyone and welcome back. It's Mrs. G again with Greenville Tech's Math 109. Today we're going to talk about section 2.4, which covers solutions of linear inequalities. So what exactly is a linear inequality? So remember from a previous math class that an inequality is a mathematical relation between two expressions that are not equal. So we could have less than, greater than, or we could have the inclusive signs like less than or equal to, or greater than or equal to. A linear inequality is simply an inequality that's very similar to our linear equations, except now instead of equals, we have less than, greater than, or the inclusive ones. So on one side, you'll be able to write ax plus b, and you should be able to move everything to one side to have it greater than 0. Here, note that a cannot equal 0, and that's just the coefficient on x, because we want to have an x term. If we're left with just a number like 3 is greater than 0, that's not very helpful, it's not true, and also it's not what we're talking about today. So remember here that the textbook gives us that definition, but it doesn't have to be greater than 0. It can be any of those signs. And it also doesn't have to be x. Remember, many of our examples show t or c or z or anything. A variable is just a placeholder and it can be any letter that you choose. Now, the solution of an inequality is the set of numbers that will make the inequality true. Almost always you're going to have an interval of numbers that are your solution. Instead of with equations or equalities, excuse me, where we had x equals whatever to solve it, now we're going to have a range of possible x values. Just like we so often see, we can do these algebraically or we can do them graphically, and we're going to walk through each of them today. Let's talk about the algebraic approach first. We're going to solve it just like an equation. So really there's no new math here. Instead of having the equals between it, we're just going to keep whatever inequality sign is there. But be careful. The only exception to that rule is anytime that you multiply or divide by a negative number, you have to switch the signs. So if it was greater than to begin with, it becomes less than if you multiply everything by -1, for example. Let's look at an example to make this clearer. Let's say that we have x minus 4 is less than or equal to 3x plus 2. We need to solve for x, so we need to get all the x's on one side and all of the whole numbers on another side. If we bring that 3x over and we bring the 4 to the other side, we're left with -2x is less than or equal to 6. Now, all we need to do to solve for x here is divide by -2. But this is where we have to be careful. We divided by -2, so we'll have to switch the sign. Instead of less than or equal to, we'll switch it to greater than or equal to. And our solution will be that x is greater than or equal to -3. Now that is a viable solution right there. So any number that's greater than or equal to -3 will satisfy this inequality. But sometimes we want to write it in interval notation. And remember, the interval notation has square brackets and open parentheses, and you need to remember which one to use where. Remember that we're going to use square brackets if we have less than or equal to or greater than or equal to. So anytime we have that equals, it's square. And anytime it's strictly less than or strictly greater than, it's going to be a parenthesis. And anytime we're dealing with one of the infinities, it'll always be a parenthesis because we can't equal infinity ever. So in interval form here, we would have a square bracket starting at 3, -3. There's a typo there. Make sure that you change that to -3 up to infinity. Now, it's always a good idea here to double check your solution. We all make mistakes like my typo that I just committed. And sometimes it's easy to drop a negative, like the typo I just committed. So plug an example back into your original inequality and be sure that it remains true. Our earlier example, we needed a value that was greater than -3 or equal to -3. So I always use, if I can use 0 or 1, I always like to use 0 or 1 because the math is just usually simple with 0 or 1. So x equals 0 is greater than -3, so it should be true. So x minus 4 is less than or equal to 3x plus 2. When I plug 0 into there, I end up with the statement -4 is less than or equal to 2. Well, -4 is less than 2, so this is true. We're good to go. If you find that it's not true, check your math in this step, and then if it's still not true, definitely go check your solution. It could just be a simple drop negative, or forgetting to change the sign, or something with a silly math example. Now we can also graphically solve these, very similarly as before when we were solving equations. We're going to use the intersection method to solve graphically first. So put the left side of the inequality into y1 and the right side into y2. This is very similar to using the intersect method in the last section when we were solving systems. Now, use the intersect feature to solve and find the intersection point. Now remember, we only want x here. We're not solving for points. We're just solving for x. So whatever the x value is that it outputs is your answer. Now remember, we don't get an exact point here. We're not talking about x equals something to be our solution. We're going to talk about x being greater than something or less than something, or greater than or equal to something, or less than or equal to something. So you need to think through and decide which side of the equation makes sense. Which one do you want to be bigger? How will you satisfy that original inequality? You may be able to see it graphically, or you may need to use a test point. And occasionally you can reason through it, like we'll be able to with one of our examples today. Let's look at an example. So suppose a software company makes a smartphone app that the cost and revenue functions are given below. We have the cost is $50,000 plus 0.02x. So the cost is going to be a fixed cost of $50,000. Consider that their rent or whatever else. They have to pay 50 grand no matter if they sell none or a million. And then for everyone that they manufacture, or I guess develop in the case of an app, they have to pay 2 cents. Now they're selling this app for $2. So our revenue is R of x equals 2x. X here is the number of copies that they sell. We want to find an inequality to describe the number of apps they would need to sell in order to make a profit. So to make any money, how many apps do they need to sell? Well, this goes back to a previous section and our intuition, right? To make money, we need to make more than we spend. So here we need our 2x to be bigger than our cost. So 2x is bigger than 50,000 plus 0.02x. So we're going to put these equations into y1 and y2. I'm going to exit this, make sure that my whole screen is sharing, and it is. And we're going to go into our calculator. So our revenue here is, or our cost, excuse me, is 50,000 plus 0.02 times x. And our revenue is 2 times x. Now we want to graph this. If we just hit graph, it's going to be in the same standard window and it's not going to be overly helpful. I don't see any intersection here yet. Now you should be able to use zoom fit here. But I will warn you that the zoom fit on this emulator, because this is software, not the actual calculator, does not seem to be working very well today. The calculator itself does not seem to be working. So let's try zoom fit and see if it fixes it. That's not overly helpful. I don't see an intersection. So I'm going to go change the window to be, I'll leave the minimum alone, but I'm going to let the maximum be 35,000. And again, you could play around with this. I've solved this problem already. We'll leave the Y minimum, and we're going to make the Y maximum be, let's see, let's make it 60,000. And let's try that, see if it's any better. There we go. That's what we're looking for, is we want to see that X right there, that intersection. So now we just go to second calc and we want to know where they intersect. So yes, this is our first curve. That's our second curve. And we wanted to guess somewhere around here, and we press enter. And it says, okay, it intersects at X equals 25,252.525, meaning that Y would be 50,505 and some change. Now remember, we don't really care about Y here. We're just looking to solve for X. So we end up with X equals 25,252.525. This is exactly what we just saw in the emulator. Now, remember that we're not looking for an equality. That is the point where they actually hit. So at 25,252.5 apps sold, they will have a break-even point. So they will make exactly zero profit. Now we can use some intuition here and know that more apps sold is going to be more revenue. And so we need to sell more than that number. You can also think about it mathematically, knowing that that blue curve, which is how much you're making, and that red curve is how much it costs. You want the blue to be higher than the red. So that sloping upwards line, the steeper slope line, you want it to be above the other line, which also happens at an X value of greater than that 25,252.5. So we will use the sign of greater than. Now, let's think about this on a practical note also. Can you sell 25,252.5 versions of an app? No, we can't sell that. So we need to make sure that we're practical here. We're going to round up and say that you really need to sell 25,253 copies because you can't sell that partial copy of an app. So our solution is 25,253 apps or more. Now, just like we saw in 2.1, we can actually use the x-intercept method, or the zero function of our calculator, to graphically solve the inequality. I tend to prefer the intercept or the intersection method, and a lot of people prefer the x-intercept method. So unless you're told which one to use, feel free to use your personal preference. To solve with the x-intercept method, remember that we're going to move everything to one side of that inequality. You're going to put that non-zero quantity into y1, you'll graph it, and you're going to use the zero function. That value of x is part of your solution. Remember, it's not equals, and you need to pick a sign. You can choose the less than or the greater than, or the inclusive versions, greater than or equal to or less than or equal to. You need to choose the sign that satisfies your original inequality. Let's look at our example from earlier. We're going to have the same exact example, and we're going to have the same exact equation, or inequality, excuse me, but we're going to solve it differently. So we know that 2x needs to be greater than 50,000 plus 0.02x. But we need to move everything to one side or the other. Oh, if we move everything to one side except for leaving a zero, we'll have 0 is greater than 50,000 plus 0.02x minus that 2x that we had to subtract. Now here, you could certainly enter this directly into your calculator. You could simplify if you wanted, but if you made a mistake, your answer would be wrong, and the calculator's smart enough to do that for us. Now we're just going to follow our steps in the calculator. So I'm going to go over here. I'm going to go back to y equals, and I'm going to clear these out. Now I'm going to enter 50,000 plus 0.02x minus that 2x, because we moved everything to one side. Now I do need to adjust my window here. I see -10 here. It's probably going to be a lot easier here to do an x min. Remember, we we subtracted it, so we're pulling it down. We're looking for the 0. So let's do an x min of -10. And why don't we just try an x max of 10, not an x max. Let's leave the x max where it was. The y max, excuse me. The y max and min, we're looking for y equals 0 because we're looking for that x intercept. So let's leave our y, let's make our y min, we can leave it as -20, and we'll just try this at 20. May work, it may not. And we'll hit graph. Okay, so now we have what looks like a vertical line, but remember we're way zoomed in and it's not quite a vertical line. So if we say second calc, and we want a 0, and so our left bound is going to be, this is going to take a second. Want our left bound to be negative, so y equals let's see. We'll just choose this left bound close to 0, and we'll choose the other left bound also close to 0. Because we want our left bound to be one side and our right bound to be the other side of y, so one positive and one negative. And we press enter. And it tells you that the 0 here is 25,252.525 and 0, which is exactly what we found before. X equals 25,252.525. Now remember that we rounded because we're talking about apps here, so we need those whole numbers. So we have 25,253. Now, just like before, we need to substitute a sign in. We know that we want the greater than sign because we know that more apps is going to make more profit. So to make a positive profit, we need to sell more than 25,253 apps. This is just like the last one, only using the 0 method versus the intersect method. Now there's one other fun thing with inequalities, and sometimes you'll see them as double inequalities. Often in words, they're written with the words and or, and all it is two inequalities being combined into one big inequality. You're going to solve this very similarly to before, okay? Instead of having a left side and a right side, you're going to have 3 pieces though. And so what you do to one piece, you have to do to all 3 pieces. Just like before, you'll keep the signs unless you multiply or divide by a negative. If you multiply or divide by a negative, the signs all switch, not just one of them. Let's look at this example. So if we're solving for x here, we have 30 is greater than 10 minus 2x is greater than or equal to 10. And just like before, we want to isolate x. So we're going to get rid of this 10 here. So we're going to subtract 10 everywhere, and we're going to end up with 20 is greater than -2x is greater than or equal to 0. And now we need to get rid of that -2. So we're just going to divide off -2. Since we divided by a -2, our signs switch direction. The equals remains on this one and doesn't ever stay on that one, but the directions change. So when we divide by -2, we end up with -10 is strictly less than x is less than or equal to 0. This is our solution. X has to be between 0 and -10, or -10 and 0. If we want to write this in interval notation, remember that there's a strictly less than here, so we have a parenthesis, -10, comma 0, and there's an equal sign on that less than or equal to for 0, and so 0 is included with the square bracket. Solving double inequalities, very similar to solving regular inequalities. You just have to do it to 3 pieces instead of 2. So wrapping up this section, remember that inequalities as a whole work very similarly to equations. You just need to be careful with your signs. You can use algebraic methods, so you can use just solving for x basically, or you can use graphical methods like the intersect or the 0 x-intercept function in our calculators. Be very careful with your signs. Truly, it's easy to drop negatives. It's easy to forget to switch. You just saw that even I made a typo, and I'm going to leave it there instead of re-recording to show you how easy it actually is. In my in-person classes, I always tell my students, make sure I don't drop a negative because it's so easy to do. And if it's easy for me to do, I promise that you're going to encounter it too. If you need more help, remember all of the resources available in our Blackboard page. Remember to practice, practice, practice. Do your homework, do your quizzes, get good grades on those, boost your grades. You get unlimited attempts. And remember that the Math Center is available at any time, in person or fully virtual. They also have review sessions, and that I am available for my office hours as well. Thanks for listening and have a great day, and I hope to see you on the next one.